Hello friends and welcome back. So in the previous two sessions we have learned in detail how we can configure the heap size for your DMGR, for your managed servers and for node agents, okay, from the IBM console as well as using the direct configuration files, right? But now when we configure the heap size or any of the parameter, okay, it is equally important to understand what is the current statistics of that particular parameter in your system. That means what is the current value and what is the utilization of that. So because when we say tuning, okay, or maybe troubleshooting, okay, so we should have an insight of our current system or whatever the currently getting executed in your system, okay, so that you have a complete clarity what is the exact utilization of the different parameters, right? For example, let us take about example of JVM heap size only. Okay, so if you have configured 2 GB of heap size for your server, okay, then you should have a clarity what is the utilization of that heap server at a particular moment, so that in case of any troubleshooting or in case of any tuning, okay, you should have a better clarity that out of 2 GB, okay, now the utilization is almost 2 GB, so I may have to increase the heap size, or maybe the heap size I have defined 2 GB, but the utilization is not going beyond 1 GB. Okay, then I may need to reduce the heap size. Okay, similarly, we have a multiple parameters. So to get the insight of each and every parameter, okay, for better tuning and troubleshooting, okay, we have a section in the WebSphere, okay, which I have explained in one of the previous session as well, which is called the monitoring and tuning. Okay, and inside the monitoring and tuning, we have four important sections. The very first is the performance monitoring infrastructure, which is called the PMI. Second is called the request matrices. Third is your current activity. And fourth is view logs. Okay, so the first part, if we talk about the monitoring and tuning, inside that we have the PMI, okay, and the request matrices, and this current activity and view logs are inside the performance viewer. So we can utilize this section, and mostly we use this section to understand the current statistics of the different parameters in a system. Basically, you want to monitor your WebSphere, what is happening inside your WebSphere, what is the current value that is getting utilized by your WebSphere at a particular moment, or maybe bit historical. Okay, so for that we can utilize this particular section. Okay, so in this session I am going to explain you about all these four sections, what is the purpose of each all four sections, okay, and what exactly we can do with the help of all these four sections, and then I will show you with the execution as well. So far what we have done, we have configured the heap size. Okay, so I will show you how we can monitor the current heap size utilization with the help of all these monitoring and tuning options. And going forward, we are going to learn the garbage collection, thread, data source, connection utilization, and many things in the next few sessions. So along with that, I will explain you how to monitor that current values or current utilization. Okay, once we will on that particular session. Right. So now let us talk about this monitoring and tuning section. So very first thing, what I said to you, we have the PMI, performance monitoring and infrastructure section. Right. So what exactly the performance monitoring infrastructure is? PMI is the main monitoring framework in infrastructure. Okay. So that means we have a framework that is auto build system, or you can say a kind of a software that is automatically inbuilt in your WebSphere, which is called the monitoring framework, which actually enable and monitor the different statistics of the different parameters that has been configured in your WebSphere. Okay, so what it does, it collects the runtime statistics from different WebSphere components. Okay, so we have a multiple subcomponents in a WebSphere, not a specific WebSphere. Even you are working on any of the application server. Okay, there are different multiple subsystems inside your application servers. So whatever the subsystem that we are going to talk here, it's not about the WebSphere. It is applicable to WebLogic. It is applicable to JBoss or any enterprise application servers. Okay, so basically what it collect, the data, that runtime statistics it collect is about the JVM. Okay, so for JVM we know that so far we have learned the JVM heap size, right? Minimum heap size and maximum heap size, initial heap size and the maximum heap size, right? Along with that we have a garbage collection that we are going to cover in the next section. Okay, then we have a thread. So every request in the WebLogic is processed by the in WebSphere, or in fact not WebSphere, any of the application server is processed by the thread. Okay, and we have a thread pool. For example, this is my WebSphere. Okay, the request is coming to your WebSphere. Okay, so here we have a thread pool where we have some limited number of threads, for example 50 threads. So if I have 50 threads, so your WebSphere can handle the 50 concurrent requests. Okay, so we should know about what is the current thread level and what is the utilization of these threads. Okay, and this is not a common thread because we have a multiple subsystems in the WebSphere. Okay, so we have a different thread pools for different subsystems. Okay, that we will cover in detail. Then we have a JDBC data source and connection pool. So your WebSphere need a connection with the database, right? So when it reach to the database, okay, so to optimize the performance, okay, what we do, we create the in ready to use connections. Ready to use connections means this is a connection which is already established with the database. If I say 50, which is the connection pool, okay, so that means I have 50 ready to use connections. So that means we can do a lot of tuning with respect to the data source and connection pools, and this particular system, okay, monitor the current statistics of the utilization, how many connections are getting utilized in the database, right? So if I have defined the 50 connections and my application is creating almost 50 connection or trying to create more than that, then definitely we need to increase this value. So we should have an insight of this parameter as well. What is the utilization of the connections in my connection pool, right? Similarly, you have a servlet. When your application is designed in servlet, then every request that is connected to the servlet create a different sessions. Okay, so we have to monitor the sessions as well. If your code is designed in the advanced Java, like the enterprise Java beans, okay, then you have to do the monitoring of EJBs. Then web containers. So if whatever the request which is connecting to your WebSphere with the help of browser using the HTTP or HTTPS, okay, which create the connection with the web containers. So we have to monitor the different statistics of the web container. Then we are executing the transaction. So once your connection is connected to the database, then we are executing the transactions. Okay, and transactions can be a single transaction, okay, which is called a non-XA, and it could be a XA transaction distributed. That means a single transaction from the WebSphere, okay, may be scattered around the multiple data sources, which is called the distributed transactions. So again, we have to monitor the transactions, right? So that means there are multiple critical subsystems in your WebSphere, okay, that we need to monitor for a better performance tuning and fun the troubleshooting. And this along with multiple other subsystems we can enable, okay, in the WebSphere with the help of this performance monitoring infrastructure, which collect the runtime statistics of all these parameters. Runtime means what is the current utilization of all these value as of now in your system. So it think of it like as an internal monitoring engine of WebSphere, right? Because it is monitoring every component of your WebSphere. Okay, so why you can do what you can do here is you can enable and disable monitoring. So anytime you want to enable or you want to disable it, this monitoring, you can do it. Okay, we can select the different monitoring levels, choose which metrics to collect and reduce monitoring overhead. Okay, because when we start collecting the different monitoring statistics of your WebSphere, okay, so it may create certain kind of a overhead, right? Because it hit your different management beans in the system for collecting the data, so it may reduce the performance of your system. So we do not enable all these always. Okay, so sometime we to reduce the monitoring overhead, we disable it, or when we enable it, then we have a different kind of a labels. Okay, so label define how much data will be going to be generated for a particular subsystem. So you can enable it, you can select the different monitoring label you want to enable or disable this PMI, you can do that one. Okay, and you can choose which matrices to be collected. That means if you want to collect matrices only for JVM, you can enable only for JVM. If you want to check only the utilization of your connection pool and data source, you can enable it only for the JDBC data source or connection pool, right? So it's not like that you need to enable for each and every subsystem. If you are going to troubleshoot or tune some of the specific subsystem, you can enable that for the that particular subsystem. So the overhead will be minimum in that case, because it will going to collect the data for some specific subsystem, not the all or complete subsystem. Okay, so now when we say the PMI level, okay, so now hope it is clear to you what is the performance monitoring infrastructure. Now let's talk about this levels, right? Because level is very important, and what kind of a data or what level of a data that PMI is going to be generate. Okay, so this is a screenshot from the WebSphere. I will show you with during the execution as well. Okay, this is inside the PMI. So very first thing is enable performance monitoring infrastructure. So if you want to enable it, by default it is enabled, this option. Okay, or maybe disabled in the latest version. So you can enable this one inside the PMI. Okay, so first, if you want to collect the runtime statistics of your WebSphere, you have to enable this one. And once this is enabled, okay, we have the different monitoring levels. So you can see here none. So even it is enabled, if it is none, then no data is going to be collected. Okay, so mostly in the production you may see this is none, or maybe you will see there's some other different levels. For example, apart from none, you have the basic, extended, and all. So all is the highest level of the statistics. Okay, so if you select the all, okay, so every subsystem is going to collect the data. That means here we have seen some subsystem: JVM, thread pool, data source, connection pool, server station, EJBs, web container, transaction manager, and many more are there. Okay, so if you select the all, okay, if you click on this plus button here in the console, you will see all the name of all the subsystems with the data which is going to be collected. Okay, so this is called the all, which is the highest level. Okay, now apart from that, we have two more: basic and extended. So basic is which collect the very bare minimum statistics, which has a low overhead. Why it is a low overhead on your system? Because it try to collect some basic information. For example, if I can say what is my heap utilization, what is my active thread count. So these are some basic collections or basic statistics that we can collect with the help of this basic level. If you go for the extended, it is bit on top of your basic. So basic collects some data, and on top of that some extra data is collected in the extended. Okay, for example, you want to check the servlet response time, you want to check what is the JDBC wait time, how many connections are waiting to get the connections. Session statistics, the sessions that is connecting to your WebSphere web containers, you want to get the statistics of the sessions. So with the extended, you will get few more options to be enabled on top of the basic one. So this is the first one, and this is the second level. Third, as I said, this is the all. So all is going to correct the every metric statistics, which you can see here. You can click on this plus button here. I will show you with the execution as well, and it will list out all the subsystems it is going to be monitored. Okay, the last one is the custom. So now custom means because here we do not have a control. If I talk about basic, extended, and all, so here WebSphere is automatically selecting some label of the component or subsystem for the collection of data. You do not have any control. But if you want to have some fine grained control, that means you want to select what all statistics your PMI should collect. So you can go with the custom, and in custom you will get a complete list. Okay, and then you can select the different subsystems or the items that you specifically want to collect the data. So you have a fine grained control over the custom. So these are the important labels, okay, which you can configure in the PMI for whatever the data you want to collect. Okay, so these are some common matrices. Okay, so this is not a screenshot of WebSphere. This is just a diagram what kind of a matrices we can collect. So some of the matrices what we have discussed so far, like the JVM matrices, you want to check what is the heap size. You want to check what is the CPU utilization. You want to check what is the garbage collection, how the garbage collection is happening. Okay, then you want to check the thread pool. What is the total number of active threads? What is the hung thread pool size? In JDBC, you want to check what is the connection utilization, what is the wait time in the database, what is the free connection as of now in my connection pool. When it is called a web container, that means the request that is connecting to your WebSphere from the browser, how many active requests are there, what is the total session count, what is the response time for the request which is coming from the browser. Okay, so these kind of a critical statistics we can gather with the help of PMI option, and this help us uh, to get the better tuning of the parameters, right? So because once you have a complete insight of the current utilization, then you can in a better situation to plan what could be the value for this parameter in my system, right? Now this is one of the real life example. Like suppose application user reports slowness. Some users are reporting that the system is slow whenever they are accessing the application. They are getting a very slow response. Okay, so what you can check in the PMI, you can check web container thread pool is fully utilized. Okay, so that means as I said, in a WebSphere we have a different thread pools. This is a WebSphere. Okay, we have a different thread pool 1, thread pool 2, thread pool 3. So for this we have a detailed session of the thread. Okay, if you just get as of now you get the high level overview, the detail will get in the thread session. Okay, so now we have a thread pool for the web container. Web container means the request which is coming from the browser to your WebSphere. Okay, it is going to the web container for the execution. So if the response is slow, it may be possible that the thread in your web containers are low. For example, the current value is 20, and maybe you are hitting the highest or some good number of users. So this may be short. You may need to tune to 40 or 50, 60, or maybe more than that one. So your web container thread pool may be fully utilized. This is one of the reasons for the slowness. JDBC connection exhausted. So WebSphere is trying to connect the database, and in the pool you have defined the 50 connections. Okay, but the demand from the client is maybe more than 50, like the 60 connection requests are coming, or maybe the 100 requests are coming from the users. Okay, but your connection pool has a limit of 50, so the request will get wait until some connection will get free from here, right? So that means your connection is going to be exhausted, so your response is getting slow. All right, then JVM heap near maximum, you have defined the JVM heap of 2 GB, but when the in the during peak load the utilization is more than 2 GB, it may be 2.5, 3, or 3.5, something like that. Okay, so what will happen if the memory is not sufficient, then the response is going to be slow. So in this case, like this is one of the case where the users are reporting that the slowness in application, you have to check for the thread pool size of your web container, the current utilization of web container, what is the utilization of your connections for the database, what is the utilization of your heap size. So this help you to identify the bottleneck of your problem. So this is the matrices. Now you will understand how important it is. Okay, specifically when we are doing the different kind of a troubleshootings. Okay, now apart from PMI, we have a request matrices. Okay, so request matrices, let me go back and show you. So here we discuss about the PMI. Now we have a request matrices as well, right? This one, second one. So now what is request matrices? So request matrices track individual request flow inside WebSphere. This is more detailed than PMI. It traces how one request travel through component. Now, what does it mean? We know that we have a WebSphere where we have deployed the application, and the different users are connecting to WebSphere from the browser. So in between, we may have a web server. Okay, web server is forwarding the request to your WebSphere, and the backend we have the database. Your WebSphere is going to database for the connections. But when the request is initiated from the user browser, okay, then it follow a specific path. The request will reach to web server. From web server, when actually each entered the web sphere, so we have a web container here, right? So this will going to the web container. For any of the database request, it is going to the database, right? So that means this request matrices track the complete path or complete flow of a request. For example, the user one tried to connect to your WebSphere. So till the request reach to WebSphere, it is executed here. The data is collected from database. The data is respond back to your WebSphere, and the response back to the user. So it is following the different channels or path here. So if the response is getting delayed, how would I know that which component in between is creating the problem? Is it the WebSphere which is causing the delay? Is it the database which is causing the delay? Which component actually is causing the delay? Right. So it track the request path, such as the request initiated from the browser. It will go to the web server. Then it will reach to WebSphere. Then depend on if your request is need the servlet, it need the EJB. Okay, the request will go to either servlets or EJBs. Okay, then if request is needed in database, it will go to JDBC. Via JDBC, it is going to connect to the database. So there would be a request flow, and there are multiple components are involved in a particular request flow. Okay, so this request matrix is going to collect total response time. What is the total response time? How much time it took to reach the request here and to generate the response, which is called the response time. Then if the request was processed by servlet, how much time it took by the servlet for processing the request. When the request sent to the database, how much time is taken by the at the database level. If your code is executed by the advanced Java like EJB, then what is the time EJB has taken to process the request? And there could be some other integrations, like if your request is going to connect some third-party system with the help of APIs. Okay, so how much time taken here to get the response from the third-party integrated APIs? So this complete information is collected with the help of this request matrices, which track individual request flow inside WebSphere, right? So what is the main use case? Performance troubleshooting, especially slow transactions. If the transaction is getting slow, like the case we have discussed, the response is slow, or maybe you are feeling that the response is very slow, transactions is very slow. Some intermittent delay. Sometime you are getting a good response, but sometime in between the response is getting delayed. There could be some bottlenecks in the backend systems. Okay, so in these situations, we can enable this request matrices to track the end-to-end path of a request to understand where exactly is taking the long time. Okay, so the important thing, request matrices create noticeable overhead. What does it mean? Because this is tracking the individual request flow, right? And there would be a multiple users are connecting to your WebSphere. So that means if you are going to enable this one, it may create some noticeable overhead. right? Because it is going to hit your WebSphere subsystem to get the response. So usually it is enabled temporarily when you have a certain issues. Okay, that means when you have some issues in your system, you want to do some troubleshooting. At that time, you can enable it, and once the data is collected, you can again disable it. But it is not recommended to enable it permanently, specifically in the production environment, unless carefully configured. Okay. Now, apart from that, we have the current activity. So let me go back and here show you. So performance matrices, request matrices, and now inside the performance viewer, we have the current activity. Now, what is this current activity? Let me explain you. So current activity, it is very clear from the name as well. Current activity, what is happening in my system right now? Okay, that means this shows the real time runtime activity of the server. Think it like a live monitoring. When the requests are, suppose as of now, the requests are hitting to your WebSphere, it is getting processed. Okay, and what is the current utilization or current capacity utilization of my data as of now, currently? That is called the current activity. Okay, so what you can monitor with the help of current activity, current request, active servlet request, running transactions, sessions, active HTTP sessions, threads, running threads, hung threads, application, current application activity. That means I have a, let me go back here. So this is my WebSphere. Okay, I am sitting right now and I'm just want to monitor the current activity. There are a lot of users getting connected to my system. My WebSphere is going to database, and then the requests are getting processed, coming in and going out, coming in and going out. Right. So that means I have a certain current utilization of each and every such system. Now you want to check what is the active servlet request in my system right now. How many transactions are running in my system right now? How many active HTTP sessions are connected in my system? What is the total number of threads which is in running state right now? If I have any hung thread in my system right now, what is my current application activity? So you can check the current activity, which is as a live monitoring, with the help of current activity section. Okay, now simple common uses. What could be the common uses? Detect hung requests. If you have a long running request, stuck transactions, block thread, live troubleshooting you want to do, then you can use this one. If server is hanging, check active requests, identify problematic application, find resources. Like, because with the help of this, we can check the current situation of my server. What is happening in my current server as of now. Okay, so you can detect the problem which is happening currently in your system, which could be the bottleneck. Now, example is, suppose user report application freeze. User trying to generate some report in the application, but it is getting freeze. So current activity shows 50 active requests stuck on the same servlet. Thread pool fully busy. So the request is getting access request is getting processed by the servlet, and for this servlet, okay, I may have the 25 threads, right? And then 50 active requests are there waiting for. So my thread count for servlets is 25, but 50 requests are waiting. Then definitely requests are going to be freeze, or the user is not going to get the response because all the threads are fully busy, right? So this indicate application code issue or backend dependency on that as well. Okay, or this could be a application issue where the session is not getting released, or maybe some lot of code issues where some different reasons could be there. Okay, so overall you can have a current statistics of your data, what is there inside your system right now. This is for the live troubleshooting. Okay, now apart from that, the last one is the view log. So what is the view log? So whatever the data that has been collected by your performance matrices system, right? So we enable this performance matrices system, and then we can view the current activity as well. But along with that, we have option, we can log this information in a log file. Okay, if you want to just like for a historical data, if you want to log some data in your system, like you enable the PMI right now, you want to enable the PMI for next half an hour, and after half an hour you are going to disable the PMI. So during that half an hour, you may have collected some data, and that you want to analyze, right? So for that, you can use this view log system. So with the help of this PMI section, we can enable the collection of data, okay, for a certain duration of a time. And once that is generated, that means once the data is generated in some log file, there is some specific process for that, how to enable that, how to generate the log file, that everything I'm going to cover in detail in the execution. Okay, and once that is generated, for example, you can see here one log file has been generated for server 1, right? So once that data is generated, then you can come here in the view logs, and then we can view the data here with the help of view log sections. So these are the four important pillars, you can say, in the monitoring and tuning in the WebSphere that we mostly use for the monitoring of the current statistics of your system, and that help us to tune and troubleshoot our system in the better way.